Hello everyone, I'm Phantom, and today we'll be working with step 3 of my project, which is stress testing and algorithm detection and manipulation. So, there are a lot of ways that you can detect the ball in this game. You can detect it based off of its model, based off of the size, based off of its red hue, but of all of them, the red hue tends to be the easiest to work with. The only issue being that it's a little difficult to detect the exact hue, especially when certain maps have color overlays, which is where having a different detection range and very specific detection hues based off of brightness comes in. Since this is a stress test, it'll simply be handling faster reaction times, although if the game likes to do as it did there, private servers don't actually handle rendering very well, so for these intents and purposes, I'll actually be hopping back into a real lobby simply because handling them in private lobbies is a bit stupid. The way that the game actually handles private lobbies is it gives you the trashiest oldest server it has and expects you to do something with it. Which isn't an issue if you don't particularly care about how fast things are loading, but when you're like me, and as you can tell by my rendering, you have an absolutely garbage PC, well, then you have a situation like here where you die and don't die. In which case I have to respawn and wait for my computer to load up the game. A little annoying, but it happens when you're playing with an absolutely horrendous internet connection. Also, as you can see there, due to how this game has the ball spawning in the center, and due to the fact that there's a red flag right over there, which is the exact same color of the ball, an oversight on the developer who designed the map, I'm sure, or he just simply didn't care. The detection algorithm doesn't work too well when the ball just spawns due to the simple fact that the ball gains progressive speed the longer distance it travels, but if it's within like the first 8 tiles specifically to the center, its speed kind of randomizes itself, which can be a bit of an issue and makes stress testing a little bit harder since you have to implement an entirely new system for when the ball freshly spawns, as you see right there, where the ball spawns, but it's not traveling at the velocity that it should be traveling. When it's detected entering my screen, it's kind of stuttering its velocity, and the program doesn't know what to do with that. So there's a lot of things that have to be put in place. This is why stress testing is in the first place. This is actually a few iterations past the previous video, and as you can see, it is handling things a bit better, especially when it's on a real server and it's able to detect colors differently. The system that I'm using in place for this specifically is an inner mask and an outer mask, the inner mask detecting red, and then the outer mask detecting red. Due to how the inner and the outer mask detect red, the outer mask is only toggled when the inner mask detects that red color. So, in other words, it will not detect the ball unless my player is red. So if there is a rendering bug, like what rarely happens where your character does not light up as red, I have a failsafe in place where if it detects my character turning red and then stop turning red without actually hitting the ball, in which case the inner area turns red over the overlay of the coordinates of my character, which I have set up here since it's not the center of the screen, but below the center of the screen by a certain amount. You detect when that area turns red, then turns not red without any red having entered the outer circle, and then if it detects that the red then enters the outer circle and is heading towards the player, it'll flag the player as being red, even if they're not actually red, which is where you implement the difference between the inner circle and outer circle activity flags. If you don't implement a system like that and you use a single flag and you simply detect when the red gets close and then try to do the math based off of pixel movement, it's a decent idea, and I do have it in version 7 of this, but it has an issue where since the starting ball gains speed at a progressive rate, it does not handle it as properly as it should. Which means you can come up with some bugs where it detects the ball moving towards you, and it detects that it's moving at a certain speed, but then the ball does a stutter, which is a weird bug that it does in both this testing version of the game and the actual version of the game, which can entirely break this system in place, especially for red detection. There are better ways to handle it, like what I'm doing right now, where I actually have a brute force system in place, where if it detects red at a certain hue and it detects him moving at a certain speed, basically checking the size of the pixels within any object that is red within the outer circle, and then monitoring if it's wide enough and long enough. Due to the fact that the ball is a circle and all characters are not a circle, you can actually implement a rather easy system where if the targeted system isn't wide and tall enough, or if it's too wide or too tall without fitting the other variable, then you can go, well, it does not function properly. And also, to prove for some people who are saying, hey, you're not, you're the one implementing these clicks, I'm going to move my mouse around the screen. So, yeah, it gets a little wonky due to the fact that I am using a library that automates your mouse movement. So I'm going to leave my mouse up here, and I want you to watch what happens when I get targeted by the ball. And this is a pretty simple situation. So I'm targeted by the ball, and my mouse has no external movement due to the simple fact also that person there has a shade of red that somehow overlaps the shade of red that I have in the system, which means I may have to fix it since it detected him in the ring as red, which is the only real issue with a script that uses color detection. Is there's no really functionally accurate way to tell the difference between other players who are red and your player who's red unless you use image detection, which is where YOLO V8 comes in, which is what my program tends to use. This specific version, version 6, well, it's like 6.9, 6.12, something like that. I've made a few iterations since it was used in the last video. It handles basic image detection by guessing the amount of pixels of your character based off of a pre-recorded length that the character should theoretically be in pixel size, and then judging whether or not the character is facing a direction by based off of the sword coming off of your character, which should be perpendicular, not parallel. So if you detect the sword coming off of the character being perpendicular to the character, detect the size of the character being, I believe it's roughly 27 pixels up and like triple that wide, then you can find the character size and you can implement a system to detect the sword, and then by the length of the sword coming out of the character at any one time. Also, there's the bug where you lag and the ball kills you despite not being close enough to touch you, which is a bug in the real game as well, which is why I'm trying to implement a check for it. But if you lag, the script can't do anything about it. If you noticed the ball does stutter on your screen, and that can throw off your timings, which means if you have automated timing like me, even if you try and brute force the timing scale, if you're lagging, it will screw up the timing. So there are ways you can implement changes for that. I have a system where if it detects stuttering, then it attempts to spam early, which, as you saw there, can work, but did not work. Spamming early can brute force if it's within close range, but if it's not, then it can get a bit difficult. Also, repetitive clicking is a bit difficult for this program due to the fact that it only checks and clicks the ball once when it's within its zone. So if you're using a simple image detection system and you're using the color red and you're detecting when it enters and then you click, you need to ensure that if the ball enters the outer zone, enters the inner zone, is reflected from the inner zone back to the outer zone, but then never leaves the outer zone, you have to have a system in place for that. Because the ball can be reflected in a clash while it's still within your inner and or outer zone, and if you check that the ball's within the outer zone and then spam the block key, you have to ensure that the ball's heading towards your character and not away from them. And you also have to have a check for whether or not it's within the inner of the outer zone. The inner of the outer zone actually applies to the fact that the outer zone that I have is a double mask, which means to state that while it is overlapped back into one mask, which is also what I do with the inner zone, overlapping it to one mask when checking the colors within the secondary check, so I can just ensure how close it is to the center. I actually have two layers of the outer zone, which is referred to the trigger zone on the outside, and then the internal zone, which is referred to the calculation zone. So the inner zone of my character ends right about here. It detects red specifically within this area and a small portion right outside, while the trigger, or the calculation zone for the outer circle expands to about here. And then, as you can see, the detection zone is out here. And that's the issue which I was talking about, where if they enter within your calculation zone outside of your detection zone, the script simply will not catch that the ball has exited and is coming back towards you, due to the fact that if you're only running calculations for when it enters the zone and not when it stays within the zone. So there are a few ways that you can do it. My favorite way is to detect which of the two outer zones it's within after 1.5 seconds, which is about the period of time that the ball would take to move to an area. And if it detects that it's within the outer zone, then it will wait a half second and then trigger the block. Otherwise, it'll trigger the block instantly. That's still within the testing phase. As you can see here, the brute forcing for it is a little wonky due to the fact that I am playing on a device that does not like to handle bad internet connections very well. As you can see here, it spawned on the detection zone, and because it spawned on the detection zone, the detection was triggered far earlier than it was moving, which is where it's best to implement extra masks to detect where inside of the excess zones it is. Some people would say that's oversaturated, that the extra calculations for having extra masks is just going to slow down the program, but just don't use PyAutoGUI. A lot of people have been using PyAutoGUI for their detection scripts, and that's just rookie time. It sounds good. You run it through ChatGPT, it'll tell you PyAutoGUI, but as an actual developer, let me tell you, that is the worst mistake you can make with your script, due to the fact that PyAutoGUI has a system in place that slows your clicks. It's a fail-safe system for human detection, and it does not function as well as you would expect. So since this entered my render zone, there's a second check right there. And there's when the second check doesn't work properly because I turned my camera. Due to how the script does detect colors and detects models, it has to be pointed straight up, due to the simple fact that if it was not pointed straight up, my calculation zone would be right here, and as such, it would be far outside of my normal reach. So the trick that you do is you have it pointed straight up, so you can handle calculations properly. The script does make me a bit nervous due to the simple fact that while this is the second to latest iteration of the script, the latest iteration having some changes to the masking, which I haven't got working on a public scale, there are changes that need to be done to the detection area. But funnily enough, to fix that, you can simply zoom in by one click on your middle mouse button, aka your scroll wheel. Since the scroll wheel controls zoom, if you turn the scroll wheel in a little bit, the detection range goes in, and well, you detect things a bit slower due to the simple fact that you're running the calculations at a different speed, since you're detecting less of the distance from you to a potential positive. It does work occasionally to give you that extra accuracy, since it's hard to tell where the ball is if you're looking straight up. And also due to the fact that that one spawn point like this that's in red will false positive you if you're using image detection of any variety, since the color is the exact same as the red that is targeted by the ball. But that's simply chapter 3, and I've been talking everyone's ear off who's been listening so far, so I guess I should get into the specifics of how the script handles its calculations and how you should probably handle calculations in the future if you're going to be doing something like this. So first off, as you can see there, that is an internal clash system. However, it simply does not work if your cooldown is not up, due to the fact that this specific training game has a 1-second cooldown that cannot be bypassed with an auto clicker. It's useful. The clash timer does take longer for the cooldown than the actual clash will last, which means that you do have to have good timing. You can't simply spam it. If you are in a clash, it's best to wait about half a second if you're going to spam it, due to the simple fact that players hit at the exact same speed usually, and if a player's clicking against you, they tend to choose a certain pace, such as 1, 2, 3, 4, or 1, 2, 3, 4, 1, 2, 3, 4. So if you go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, you'll throw off their timing. which is useful for a lot of people who use macros like auto-clickers, because those macroed auto-clickers are designed to run at the fastest pace. But if you manage to alter the pace, whether through the use of abilities or through the use of modifying how the timer reacts, you can set up a system that allows you to bypass most of those macros in a clash. It's not perfectly accurate. Any good macro should have human-like interactions, which means that it should have some form of random variable for the time clicking within a certain set. But since they're going between 0 and 1, or 0 and 1.5 if they're smart, the only real chance they have of generating is something between 4 and something between 6. So 4 being 0.45 up to 0.65 being the change in the variable. But for image detection specifically, especially in this case, you cannot just detect red on your screen. I mean, you could, but even if you detect red on your screen and have it wait for a second, you'll never be able to detect whether or not the ball is moving at a functional speed. And if you want to detect if the ball is moving at a certain speed, you can't do what I do, where you look down and then accidentally hit the detection range while you're not properly timed. But, well, that's interesting. Ball spawned on me. Ball spawned on me 3 times. That's lovely. On me 4 times. There we go. Had to get out of that little spawn loop. There's not too much to talk about. I haven't seen any of the users who have been watching these videos asking any particular questions about how the program works, or about speed of the program. And for most of you, if you ask, you wouldn't really understand exactly why the speed matters as much as it does and how fast this is running. I'm actually using multiprocessing. It tends to be the best choice when you're working with these kinds of systems. Image detection should be run on a different core from the rest of the program. That way, you handle the clicking separately. And people may ask why to use multiprocessing in a script like this, and it's actually pretty simple. Image detection takes a lot of your core usage. Your CPU is going to be used a lot more when it comes to image detection than it is to all the other functions in the script. Image detection is a large majority of the script. Things like timing and stuff like that can actually be timed out using your system clock, so you can start the timing from the second that the function is run. So you just tie the function to the system clock to detect down to milliseconds when each screenshot is taken, and then tie that based off of its metadata to your actual current system time, or in Python's case, I think it actually handles most of that for you automatically, which is, nice. But outside of that, functionality and timing is always a bit difficult. If you see here, a lot of people tend to just not respond to the ball. That's because I have a feeling people have been copying me. In fact, I know that's the case because I was working on a AI aimbot that I had let some members of the community know that I was working on, and I'd even explained how it functioned in layman's terms to a few people, and then a post came out the next day using my exact method, using my exact model, just with ChatGPT generated code, which is rather hilarious because ChatGPT generated code tends to have the bad issue of it's about 6 to 8 months out of date. Their model doesn't live update anymore, so yeah, that means that. Yeah, so see right there, people like that, they do have the advantage if you don't have a clash system set up properly. Since my clash system does not deal very well with macros or people that are clicking at the exact same speed, or, well, modifying themselves by like a very low 1.25 or something like that, where their clicking is progressively getting faster by a very set variable, the system I have in place doesn't work very well. It still has to time how fast it's moving. But if a player doesn't get within my detection range while they're doing that, then it's fine. There's a secondary detection range. Also, aiming. This version was something that I mentioned would have automatic aiming. However, due to some issues with debugging, I never actually implemented that. As you can see there, when the speed gets above the 4th or 5th hit of the ball, it's moving fast enough that the ball usually is within the first trigger zone. So setting the second trigger zone to function as a trigger zone if there's no red ball within the outer trigger zone, but there's red within the inner sphere is the best way to handle that. So you set the first sphere, which directly surrounds the player. It should come off a little bit from the player just in case if the player is rotating and the screenshot takes a photo while they're moving and their leg is out, you see your model slides forward and backwards. So you should account for that in your script. So when your player's not moving, they have a different model than when they're moving. And when your player's turning, their hands swing out. So you should attempt to detect their hands. You don't have to, you can just detect the very top of their head, which will always overlap with their back while they're walking forward with the camera like this. You could even set it to like 10 pixels or 5 pixels, or not even set a radius and just set it to the center pixel if you're so into that. Assuming you know where the exact coordinates of your player is on the screen, which you can do through any kind of project. But for auto-aiming specifically, it's actually quite simple, and the only reason I didn't implement it in this specific version is because I was testing it with the new masking version that I'm using. But all you have to do is detect the ball coming towards you. Detect the angle the ball's coming towards. In this case, it's coming from D, and then you hit A. So as you can see, due to a bug in the code with how the ball's aim is detected, it's very hard to pick up where the angle's going to go, unless you know where the ball came from. So, like there, when you toss it behind you, that's actually abusing an exploit with the fact that it will go in the direction you're facing unless you're moving two directions simultaneously, such as hitting D and then hitting W, which I'll show you here in reverse. So, when you're moving a direction at an angle, it'll actually cut to the 45-degree angle of where you're facing. The only exception being is if you choose to turn your face while moving constantly, in which case it'll drag the ball in front of your character, which will be here, and it'll drag it to your next movement, as such. So due to that, you can do a fun little thing that I have been working on where you move down while then hitting W to keep your face forward. And what it does is you let go of W before you let go of D, but your character will shift slightly, and as you can see here, when it detects out there, that close to the white area, which is something I need to work on. If the white overlaps the red, which is a system I'm working on, it's just going to set the ball's detection speed to half speed, which should fix the issue with the spawn. Since the ball detection speed is checked every time a screenshot is taken, you set it to where the first 10 screenshots after it detects the red being in white, it sets the ball speed to half speed, and then it updates the algorithm for detecting its speed back to normal speed, which has been showing a lot of promise in this Gen 7 model that I've been using, but it's less effective in this specific version due to how I detect the color and how I detect the player model. But yeah, by doing that like so, despite the fact that I'm facing down, the ball goes up. Like there, despite facing to the right, the ball goes left. So using that method in place, that can be used by any player in the real game as well. It doesn't have to be a bot, but what I can do is detect the angle that the ball's coming from and then purposely use that glitch to have my character hit the ball behind me. It's a method that no one really uses because due to the fact that it does exist but isn't properly used in any game, since most people just go directly into clash with auto-clickers, when this game patches clashing, which I don't see happening anytime soon, but I do see them attempting to patch auto-clicking and by accident patching clashing. When that happens, this method of being able to reflect the ball in a different direction than the game sees you aiming, so other players see you aiming in a different direction than you're actually aiming due to this glitch. So right there, it got the trigger because I was moving and my mask is set so low, which the inner mask detects red, which then detects the outside. The issue is if your inner mask and outer mask overlap, which is what happens where I have 3 different masks. I was doing some mask testing on this, and the masks overlapped partially, which means that I would accidentally cause false triggers very occasionally in the detection software, which is what's happening here. But that's easily solved by simply reworking the algorithm for each detection and adding a system. So as you saw there, that's a bug that does exist within the normal game. It doesn't have to be when you're lagging. You can hold the ball for a short period of time. I originally attempted to have the script like limit my Wi-Fi speeds so I could do that every time. It's where anytime I would hit the ball, it would let me rotate it, but it honestly felt like cheating. So it just, I mean, this is obviously cheating as well, but it's a different kind of system. That was too easy. Like, you just hook this up to a rate limiter, and you rate limit yourself for when it detects the ball, and then you pop the rate limit off in like a second and a half, and then that lets you grab the ball, hold it, and then rotate to whatever angle you want. So it's entirely extremely easy to do if you're using Python, since you can just tie it to Python libraries that already exist for that exact function, especially whether if you're on Windows or Mac OS. But since I had originally planned to launch the script in a public sense, it didn't make sense for me to use a OS-specific function, which is actually why the script is not built for Mac OS at the moment. It uses a Win32 API for the mouse event rather than the PyAutoGUI, simply because I'm tired of using the PyAutoGUI for everything. Also, as you see there, that's the hold. Other players see it bounce off of you, but in reality, they'll see that it sticks to you for a second. That is something, it will bounce off of you, but it does stick to you for like half a second. And that half a second is visible by all players. So compared to where a normal player, where you see them reflecting it before it even gets to them, which, by the way, if you wanted to do something I was testing earlier, you can actually do something where you move the ball calculation off by a certain percentage, and that lets you hit the ball from further away. So instead of detecting when the ball gets within a certain number of pixels, you just multiply the number of pixels. But due to how the calculations work, the calculations are pretty extensive, which is why you run those with multiprocessing. That way they can handle it. But that is Chapter 3. Chapter 4 will be coming out soon, and I apologize for talking everyone's ear off, but explaining how this program works, so hopefully in the future, when executions on mobile are blocked and people want to play and use these kinds of things, they'll be able to. That's entirely up to everyone to figure out, though. When injectors do get inevitably blocked on mobile, which will likely be happening sooner than later, and as you see there, because of how the guy jumped, and because he stayed within my detection range, yeah. But when mobile detection is blocked, which is going to be relatively soon, looking at how the system currently works, these kinds of scripts are either going to become active or they're not. And while it should be better for them to be active, people have been so focused on injectors that they weren't thinking about external exploits, external ESPs, because, oh, you could just inject code to pull up a library to load the ESP in-game. But then what about games where ESPs didn't function properly because, they had an anti-cheat that detected when you injected into them? Well, people just found bypasses. It's easier to bypass than it is to program an entirely new script to handle it for you. I mean, it's not like you can just, set up a kernel, start doing memory reading directly to the program, and getting all that information back, like where player model locations are and things of the like, and then just generating a simple ESP off of that, putting up a box above where it detects the players, and putting their username above it, since that's all information that the client sends to you. Nah, that'd be too difficult. It's far easier to use an injector that's been around for 10 years. That's so much easier and so much more functionally effective for people who don't know how to program, who kiddie script with Lua. And that's why things like these haven't come out, due to that kiddie scripting. But, well, that's just life. And I thank everyone for watching, and have a great rest of your day.